Also, if you have a circuit and you want to find Thevenin equivalent for it, it is very important to find Thevenin equivalent for some reasons. If you remember, when you have, if I want to calculate Thevenin equivalent between A and B, I replace the whole circuit by what? By just voltage source and resistor. But here we have impedance, not resistor, because we have imaginary number, imaginary, real and imaginary. So we call it impedance here, Z Thevenin, and we V Thevenin. By doing that, it will be very easy for us to calculate any current in between A and B. So if you connect any load here between A and B, you can calculate the current very easily. Okay. Also, we can decide which load will give us the maximum power transfer. This is from circuit 2, also circuit 1. If you want to calculate, if you get a power here, source here, load that give you the maximum power transfer in real part, when you have resistor in DC, RL here supposed to be the same like R7. But in complex, the impedance that you connected here to give you maximum power transfer is the conjugate of this one here. Is the conjugate, which means that if this is Z7 and, for example, 12 plus 4 minus J 3.2, then the impedance that you connected to A between A and B that will give you the maximum power transfer is 12.4 plus J 3.2 plus J 0.32. So in this case, the negative and positive will cancel each other. The imaginary will cancel each other. This will give you the maximum power. Okay, so this is why Thevenin equivalent is important in general. So how we solve it? We solve it the same way. First, if we have, this is the circuit. Okay, it is already converted here to phasor. So what we need to do is find V Thevenin and R Thevenin or Z Thevenin in this case. Okay, if you want to calculate V Thevenin, which is the voltage between A and B, here is the circuit. Here is the circuit. What is the voltage between A and B? The voltage between A and B actually is the voltage across this capacitor. Why? Because this resistor here does not have any current. Will not have any current. This resistor, 10 ohm, will not have any current. Because if you have a source like this, the source will create a current here, and the current will continue, will not go here, of course, this open, as it will come through the resistor, the capacitor, and will not go through the resistor because it's open circuit. So it will return it back like this. So V between A and B, V Thevenin, is the voltage across the capacitor. Okay, so if you want to calculate VAB, you just find the current here in this loop, this current, and multiply it by this impedance. This will give you the voltage between A and B. So according to this, VAB equal what? Equals the current. What is the current? The current equal 120. Okay, 120, this one here, divided by the total impedance in the loop here. This is the current. So the current is a voltage, 120 degree, divided by what? By the impedance, 6 plus J2 minus J4. So it will be 6 minus J2. 6 plus J2 minus J4 will be 6 minus J2. Okay, so 120 divided by 6 minus J2. You multiply it by what? By this impedance here. Negative J4 times J negative 4. Negative J4. Okay, so this is a regular method. Some people do it this way also, the same way. It is actually the same equation, but in just different way. So what I did here, I used a voltage divider. So I said the voltage here equal what? Equal this impedance divided by the total impedance times the voltage, which is the same, exactly the same. There's no difference. Okay, so what you need to do is just convert this to phasors here. So negative J4 is 4 and angle negative 90. This is 120. This one is 6 and negative J4 will be 6.32 and angle negative 18.43. Okay, so you calculate this one. You multiply the amplitudes. 4 times 100. So let us see here, this one here, 4 times 100 divided by 6.32 equal 63.29. So this is amplitude. The phase is what? Is negative 90. Here is negative 90 plus 20. Okay, because you multiplied by 20. Negative 90 plus 20 minus minus will be plus 18.43 equal negative 53.57. So this will be the voltage V7. One thing to remember here is how do you convert this one from amplitude, from real and imaginary to phasor. So remember what we said before. We have this one here. We know that this one is 6 minus G2. Okay. So here, this one, the amplitude is 6 square, which is 36, plus 2 square will be 4, square root equal 6.32. So it is 6.32. What I am interested in here is angle. What's the angle? Is it negative 18? Let's see. So here it is negative 2 negative divided by 6 equal, and inverse 10. So the angle is negative 18.43. Okay, 0.43. But is this one is right or not? Because as I said, the calculator will not differentiate between the two cases. If you have 6 minus G2 and negative 6 plus G2, it will give you the same answer for both of them. So to decide if this is right or not, let us see here. The phasor, the numbers that we have here, 6 is positive, so it is positive 6. This is the real, and the imaginary is negative. So the angle is supposed to be here. This is the angle. So it makes sense that it is negative 18. Makes sense, it's negative 18. So this is right. Okay. So this is the Thevenin voltage V between A and B. What about this Thevenin? For this Thevenin, you turn off the source. So the voltage source is short circuit. There it is, short circuit, and you calculate the total impedance between A and B. So here you try to simplify the circuit step by step. If you have two elements in series or parallel, you can do that. So here, of course, this one here is what is this one here. This one is 6 plus J2. Okay, this one here is parallel with this one here because they are both connected to these two nodes. So they are parallel. So you multiply and divide by the summation. You multiply 6 plus G2 times negative G4 and divide by the summation. Here, this is what I did here. Okay. 6 plus G2 times negative G4 divided by 6 minus G2 because it is G4, negative G4 plus G2 will be negative G2. And of course, to simplify the multiplication and division, you have to convert them back to amplitude and phase. Okay, so 6 plus G2 is 6.32 and angle 18 and angle 18.43, 6.32 and angle 18.43. And here this is 4, the amplitude is 4, and negative G will be negative 90 degree. And for this one will be the same like this. Like this one here will be 6.32 and angle negative 18.4. And then what you need to do is just try to calculate the amplitude. The amplitude will be 6.32. Or here you can cancel 6.32, cancel with this one. So it will be end up with 4. Okay. And the phase is what? You just add 18.43. Here it is 18. Oh, come on. 18. Okay, 18.43. Okay, minus 90 or plus minus 90, as in minus will be plus, so plus 18.43 will be negative 53, so here it is. So 4 negative 53.14. So this is the impedance. You can convert it back, of course, to real and imaginary. How do you do that? You just say that it is 4 times 53.14 negative, and you hit cosine. Okay, equal. It is 2.4, almost 2.4, and 4 times 5, 3.14 negative, and you hit sine. Okay, and say equal will be negative 3.2, negative j 3.2. So this is the parallel here between these two here. Okay, so once you do that, you will have a circuit like this, very simple circuit that has only this 10 ohm. This is 10 ohm, and you have another impedance here like this, and this is actually the impedance. It is this one here. So we add this one here. Okay, so now of course they are in series. Then it is 10 plus this one here will be 12.4 minus j 3.2. So this will be the impedance. This will be the impedance Z7. So the circuit, you get the V from here. This is the voltage, and this is the impedance Z7. And as I said before, if you have to find, for example, what is the maximum power transfer, or what is the load that will give you maximum power transfer, it is a load between A and B, which is conjugate of Z7. So it's supposed to be 12.4 plus J 3.2. So in this case, if you have a 12.4, okay, plus J 3.2, then in this case, when you add them, because they are in series, negative J will cancel positive J, then the total J will be 0. Then you add just 12.4 to 12.4, so it will be for 24.8. So the total impedance here will be 24.8 ohm resistance here, so supposed to be resistance. And then of course you can calculate the power here very easily. Okay. Last slide here. This is the assignment. The assignment consists of 4 problems, as you see here. These problems are already solved. I solved all these problems, but you will find this one, this one, this one in the handouts. You will not find this one in the handouts. You have to watch these videos to see the solution for this one. Thank you very much for watching, and see you in the next chapter.